Hello, everybody, and welcome to today's introduction and overview session of the certificate program in Python for Finance. You see here the focal topics listed: algorithmic trading, computational finance, and asset management. My name is Yves. I'm CEO and founder of the Python Quants, as well as the AI Machine. So today's session is meant to give you a brief overview. It will take a little bit, nevertheless. I would consider it brief, given the breadth and the depth of topics that we cover in the program. I think over the years we have grown the program to almost master's level in terms of what we cover. Not only in terms of like the requirements and then the level of the presentation itself, but also in terms of the breadth and depth with the starting classes, which we call the basic classes, right? And everything else that we've added over the years. So basically the program has been growing every time since we have been started with the program. And to give you the briefest overview, here you see the agenda of today's session, and you see quite a few bullet points here. Of course, there's a brief introduction, then the program from a high level point of view, a few words about the Quant Platform, which will be your central go-to resource where you find everything that we offer that is required for you, where you can execute code, where you can read text, where you can watch the videos, where you have the user forum, and a bit more. We then have the mathematics basics class, which we have recently added. This is about 45 modules these days. Performance Python for Finance Basics, where we also cover certain performance topics, is another basics class that we have added, where we focus really on the most important Python idioms, packages such as NumPy, Pandas, Matplotlib, etc. Right? Crypto Basics is a class here. Finance with Python, and you see here the twist: your finance comes first, and then Python is a class which introduces fundamental finance concepts by the use of Python. Of course, a little bit of mathematics is always involved and required. Tools and skills is about working with Python environments in different contexts like Docker containers, cloud, but of course also locally. A few more tools such as Git version control or Vim for editing, cross-platform, and a bit more. Financial packages is something that we just in the last cohort added. It is a class, and I would say this is more or less a starting point. It now currently stands at 6 modules, which introduces you to pretty important, efficient, and powerful packages dedicated to financial problems. So when we talk about NumPy Pandas, that is used efficiently in the financial domain, but this is also used in many other domains. But there are, of course, a couple of packages these days. They're also growing and becoming better. That cover financial topics and aspects where we don't need to reinvent the wheel, although I'm a big fan of at least knowing how the wheel was invented, and so that you have, let's say, your programming background without diving directly into the high-level packages, right? Python for financial data science at the core of everything that we do with regard to data processing, visualization, statistics, stochastics, etc. Python for Excel, I think the name speaks for itself. So it's about the integration of Python into Excel. Python for databases, similarly important topic when you want to work with larger data sets, or in, let's say, a corporate context. You are faced with SQL databases, relational databases, say. This is where also Python can be used efficiently. NLP, natural language processing, so important these days. I think when people speak about AI, the large language models come these days, at least immediately to mind, since the last couple of months, since November 2022, when ChatGPT was published. This was really kind of like where the mainstream media started covering everything about these large language models. But here we are not yet covering large language models. This is, if you like, the precursor, and it shows you this. I must say it's one of the shortest classes that we have, the NLP class, but it shows you how to process unstructured data, text in that sense. In our program, we have different classes, 2 about AI and finance directly. One is more fundamental, building deep neural networks, for example, from scratch. The other one is a little bit more high level, applying TensorFlow and Keras to different problems in finance. Reinforcement learning for finance is also quite popular these days. When you have a look at recent survey articles, the literature here and the research is growing, which I find pretty fascinating. So Python for algo trading, computational finance, asset management, these are the core classes, and usually towards the end of the class of the program, you don't need to worry today about the final project because it's the final project. But towards the end, you're supposed to decide in which of these core areas you want to prepare your final project. Case studies and demos. I've shortened this a little bit for this round of the introduction and overview because we have so much to cover. But I nevertheless want to show a little bit of code so that I'm hopefully able to whet your appetite for the topics to come. Study plans are there, two basic ones, I would say, the one for the live cohort and the other one for people who want to do a self-study. We will go through these briefly. Then a few words about the guiding principles for the program and what to expect in terms of presentation, coverage, etc. Reviews, exercises, test project. This is something that I've been asked already beforehand. If we do have stuff that can be done where you can test yourself, where you work on specific problems, and yes, this is our tutorial class where you find reviews or also review questions separately, and in the tutorials you find exercises which are starting from pretty simple, pretty close to what is covered in the program, to quite involved in the form of test projects that might lead you step by step then to the final project. In terms of support, we have the user forum. That's for everything technical, content related. If you want to post code, etc., this is where the user forum comes into play. The Discord server is more used for organizational questions, or if you want to discuss with others about, I don't know, career perspectives, or want to discuss ideas for the final project, let's say, then the Discord server comes into play. Of course, you can use them, as is the benchmark for online platforms 24/7. Now, a brief introduction for those of you who haven't really heard about what we do. Yeah, Python for finance is, if you like, our business purpose. The Python Quant says it hopefully as well. Our company name, we provide services, training, we run platform, we have open sourced a few packages, written a couple of books, have come up with our certification here, the first in Python for finance, with the specific topics that you can cover, and we run events as well, such as meetup events, or in the past we have run live bootcamps, or like last week where we have run an online bootcamp, right? So that's basically it. It's a relatively long list for a small boutique firm like we are, but we focus really at the core always on Python for finance. So we have our platform, the AI Machine, which is for proprietary AI-powered algorithmic trading, but this is of course integrated, but still separate in terms of team and platform and what we do in this context. If you fancy to read a bit more about my personal background, here you see it. I'm not going through it, it's just for your reference. With regard to the books, here is the most recent book that I have published. It's Financial Theory with Python. This was an outgrowth of the Finance with Python class that I mentioned before. It really introduces fundamental concepts in finance and models, theoretical constructs and approaches in combination with the required mathematics, at least to some extent, or as much as required, and the Python topics and idioms themselves, right? My reference book, Python for Finance, now has been translated into multiple languages. The most recent one, which is right behind me, my second desk, is Python pour la finance. It's in French. I'm pretty happy about that. So I live near the French border here in Germany, so that it's now available in French. It's kind of nice for me. What I'm still missing is the German version for it. So maybe I, in the end, would need to do it myself. I don't know why that's the case. Here you see also another Asian version. There are basically Chinese versions, Japanese versions, as well as also Korean versions. There are a few of them. They have been translated into Asian languages, which makes me happy as well, because of course it's a pretty large target market with pretty active, not only people in finance, but also financial centers, right? Python for algorithmic trading, you might have guessed it, an outgrowth of the class that we've given now since years in algorithmic trading, AI and finance. I said it before, at the core throughout the program. You see it in many different classes, places, some of them fully dedicated to it, and some other classes it is kind of like one of the topics that is covered, or machine learning, deep learning is used as a means to an end, for example. So you will see a ton of examples in this regard. That's my background, quant finance. So my PhD was in mathematical finance back in the days, and these two books are about quant finance topics where Python obviously is used to implement the numerical methods. Now about the program itself from a pretty high level, and that means just with regard to the numbers that you see here, it's a 16-week program, or of course you can do it fully self-paced. So everything that is done, if it's live, it is recorded, it's put on the Quant Platform. Everything that you are supposed to read to do is on the Quant Platform, so you can do it 24/7. You can study a little bit more slowly, you can study a little bit faster if you like. So all the options are there. I know many of you will implement kind of a mix of an approach where you select the live classes that are interesting or important to you and might study asynchronously the other parts of the program. And on top of that, given the resources, I would say hardly anybody gets through all the resources, even when they study more or less full-time over 16 weeks. But you have indefinite access to your own resources, to what you have booked with us. And even if there might be some updates, some new runs for certain classes, you will have access to them as well if they are part of your own package. So you can study 1 year, 2 years, or as some have been done in the past, even over multiple years, coming back to the platform or checking out new stuff or repeating maybe things where time didn't allow to go deeper in the past. In summary, we have a ton of resources for you, and the resources are growing, and you have basically indefinite time to master them all. Even if they are updated, you can still revisit them and then have a good overview. Here, one quote, because still many people say, well, why Python? Why not X, Y, Z? And I don't want to compare Python with regard to strength and weaknesses to others. I think there's no doubt these days that Python for finance has become a key skill in the industry. When you have a look at job postings, etc., whenever there's something quantitative involved, Python is one of the requirements. So if you want a banking job now, you need to code in Python, and this hasn't been the case. So for years, the banks have been, like so many others, have been hiring MBAs, and these days more and more quant skills are required. So if you're trying to get into banking now, here you see, and Python will get you a job across the banking industry in anything from sales and trading to portfolio management and risk. It's one of the skills, or it's the one skill that really differentiates applicants in the recruitment process. Maybe that's still the case. The quote is from 2021. I would almost see that you need to be good at Python for finance in order to differentiate yourself. And that's what our program is about, to bring you maybe not to just a blue belt level, but rather to one day the purple belt, brown belt, and even if everything goes well, to the black belt level. So the Quant Platform, I said it before, and I will do a brief demo afterwards. I mean after the introductory part. Anyway, so everybody should have their login credentials. There are also a couple of resources, but about the platform I want to say, but overall it should be all self-explanatory. I hope at least it's not that complex in and of itself, but there are a couple of things that I want to review briefly with regard to where to find the resources, how to execute, for example, code, user forum, etc. Right, so now to the first class, which I always saw as an introductory class. But when you say, well, I start with the introductory class, you will quickly notice that there are 45 modules. That's already 45 hours. It's not only that you watch it like, let's say, a show on Netflix, right? There's also quite a bit of stuff that is covered. So if you want to internalize, if you want to learn about the details there, this might take you already quite a bit. You don't need to do it up front necessarily. You can always do it also in parallel. Let's say that you pick 2-3 of them per week as one approach, right? And then go through them. If you say, well, I want to get maybe a head start with the class, maybe you do a few more of them together and then turn your attention to the other classes. So overall on the Quant platform, you will see that we have usually the videos with the resources like the Jupyter notebooks attached to them, which you can click, and then the Jupyter Lab server on the Quant platform opens, where you then can execute the code, right? You can also, this won't be permanent, but if you say, well, I want to do my programming here on the Quant platform, so that I have mentioned that you can also install additional packages. For example, if a Python packages might not be found, and you say, well, I want to try out X, Y, Z, or I need that for what I want to do, then you can install it, but be careful. This might not be permanent, what you change there. But Math Basics class is about reviewing fundamental mathematics concepts based on simple Python code. So here it's really the introductory aspect that is in the foreground. Then the other basics class, which is pretty long, like in the mid-30s, like 35 classes, Python for finance basics. Same structure. You find the videos plus the resources like Jupyter notebooks or Python file scripts that are used there, plus links to the slide decks, etc. And when you click on the Jupyter notebook, you can open it here on the platform, or you can from there also download the Jupyter notebooks if you say I want to rather execute them on my local machine instead of working always on the Quant platform. Or for example, I don't know, you might go on a trip, sitting on the airplane, having no proper Wi-Fi connection, then you might also download selected resources and use them on the go. Python for finance basics, really here the focus on basics. This could also be set in bold with underscore, right? It's about the basics because Python for finance is obviously the overarching topic for what we do in the program, right? Crypto basics. This is similar in structure, similar approach. Basics here is the focus, and yeah, it covers topics such as encryption, such as hashing, yeah, different technological concepts, approaches, packages, tools that are important. Generally speaking, in the crypto space, not necessarily only for cryptocurrencies and cryptocurrency trading, etc., but overall with regard to encryption, right, where this all is coming from, where you also learn how to encrypt, for example, local files with your passwords or whatever. So it's instructive beyond the application to cryptocurrencies. That is the message here. Also, password cracking, for example, is one of the topics that is covered. Now, finance with Python. This is where we would say, well, after the basics, we now have yet another basics class, although there is the word basics is missing. This is indeed about the introduction of financial topics, plus a little bit of math, as I was saying before, plus the appropriate Python code to implement the mathematical financial concepts and to work with them. So here, topics that are covered, and this is traditional financial economics, I would say, are two-state economies, which are called static economies, the fundamental theorem of asset pricing, three-state economies, where we can discuss incomplete markets, right? Also static multi-state economies, so generalizing the state space, dynamic economies, modeling uncertainty over time. You might say, well, this is all pretty theoretical, and indeed, that's the theory behind so many of the models that are often used as blue box as black box implementations, where I say, well, I feed something into some black box and something is coming out there, right? Think in terms of the option pricing model from Black's Scholes, right? This is not covered in every detail in this part, but at least to a large extent, you will internalize the ideas behind the workings of the Black's Scholes. So because why am I saying that? Yeah, Black's Scholes requires stochastic calculus, and that's really advanced mathematics that is required. And for such an introductory class, this doesn't really work. But more details, for example, are then presented in a computational finance class, where hedging, option pricing, etc., is one of the core topics, obviously, right? So here's starting point, basic notions, ideas, and then later on a bit more of the involved side. You have access to the text of the book. You have access again to videos, to Jupyter notebooks, etc. And if you wonder every once in a while there are questions, this class doesn't have a text or a book, and that's often the case, right? It's not for every single class that we have is a book available yet, right? I'm currently writing another one, but this is about reinforcement learning for finance, actually. But there are classes, and there are in particular also shorter ones where there is no book available for finance with Python, for financial data science, for algorithmic trading, for AI in finance, etc. There obviously are the texts and the books available. Plus, that's true for all the classes, video recordings, resources, and executable code, right? So that's always there. And at this stage, I like to briefly go into the Quant platform. So I should be logged in. Usually I'm always logged in there. The Quant platform. Let me just check on the other side, a little thing there. Just a brief thing there. Yeah, so when you get started here on the Quant platform, when you are logged in, this is what you see in general. That's the dashboard. On the dashboard, you see currently the latest 3 video recordings. So here you see the 3 recordings of last week's Python for Finance bootcamp. Some of you might have followed along. And this was, if you like, a quick run through some of the important topics that we cover in the program. Of course, with a 3-session bootcamp, you cannot go through everything. You might have guessed that, given the numbers that I've presented before for the program. Right, but I guess we've covered quite a bit there. So having said that, you see that there are the 3 recordings, and this is really in chronological order. So that's the latest one here is PFF Bootcamp 03, right? And you can here click on it, for example, and it shows you the recordings that are available there. Let me just check. Yeah, I'm in the right account because I have multiple accounts here, obviously. And as for the others, you see here Jupyter notebooks, and every once in a while also Python files or whatever might be available in the the context of such a module. Right? But these are just the latest one. When you now ask, finance with Python, where do I find the resources? So first of all, here you see about the books, right? And there is Financial Theory with Python. That's the reading text for it. This requires a password. You have received the password with your personal welcome email. Once you open this, you see the full text of the book. Right, this is some 200 pages. You see here the chapters: finance with Python, 2-state economy, 3-state economy, roughly what I've presented before, down to the dynamic economy, where models such as binomial option pricing, according to Cox-Ross-Rubinstein, is presented, and the Black-Scholes-Merton option pricing model, but in a simulation context, not, as I was saying before, based on the stochastic calculus, which is the traditional approach. But in any case, you find here all the resources in terms of the text, right? When you want to read, want to get more background, you can go through the text, read it up front, or as some prefer to do maybe afterwards. It is, well, first I have a look at the session, then I have a look at the code, do it by myself, and then I add context and details to what I've learned. Some people say, well, I want to have the details first, and then this makes it easier afterwards for me to study the code. Both approaches are, I guess, valid. You, I would say, know best how you learn most efficiently, how you internalize, how you practice best. And I must say, reading just the books, reading just text won't make you a black belt Python for Finance programmer, practice should be coming first. So whenever you face the decision about limited resources and you're asking yourself, shall I go and do an exercise and do some programming as compared to reading the assignments, or going through the reading assignments, right? Then you should prioritize the practical part, the coding part. You can always get back to the text, etc., right? But exercising, programming, that should be in the foreground. So when I go a little bit further down in the book, here you see like it usually looks. You have a little bit of code. The code is explained in this book more or less step by step, code line by code line. You also see a little bit of finance here and mathematics, which explains what's going on. So you have financial notions, ideas, you have the mathematical, sometimes formulae accompanying it, sometimes other equations or whatnot, right? And then you see the implementation in form of the Python code. So that's the approach of most of the books, but here indeed it usually starts with finance, the ideas, then adds the mathematics to it, and third, the Python code is added. So that's the reading part, right? So that's in here. Let me get back to the dashboard because we're here in the online training part, right? But the menu is obviously accessible from all the areas. Then if you like, there's also an HTML version. That's the, if you like, the old financial theory with Python book, which is called Finance with Python. I would recommend to read rather through the nicely layouted PDF version of the book by O'Reilly, right? This is the HTML version. You can click on that. It's still available. It has certain advantages with regard, I would say, maybe searching, integration, navigating here on the left-hand side. But overall, if you're undecided, I would say go with the PDF version. But it's there, and we, for the time being, leave it there. So now here in that part, you find Finance with Python as a class with the videos, Finance with Python 01, and in the study plan for the first week, I can open it already here. You have a short link to that as well. PPQ, this was updated today. And you see here in the first row, week number 1. And in week number 1, you see Finance with Python 01, 02. This relates to the videos, to the sessions. And here you see the reading assignment. So I had opened before the PDF version, and this says that you should go and read the first 3 chapters because they relate to what is covered in the first 2 sessions. So for the first 3 weeks, this is all about the basics here. So the basics in finance with Python, plus we get started with tools and skills, financial data science, AI, and finance, and a few optional things. And on the right-hand side, you see the live sessions to which you should have received invitations already. But what I wanted to emphasize here, the connection in the study plan, Finance 01 and 02. This relates here to Finance with Python 01 and 02. So when you get started, you would click here on the video. Now I will be hearing myself, so let me mute that. So that's the video, right? And you can go through it, you watch it, you learn about the details. That's, if you like, the very first element of the study plan, and maybe it's the very first thing that you want to pay attention to over the course of this first week. You have here also the option, this was a request in the past, to play this faster, for example, 2 times. Some people prefer that. When I listen to audiobooks, I always do that. With regard to videos, I'm not yet in there. Maybe 2 times for me, it's a bit too fast, right? And on the upper left-hand corner, when you click here on the menu, you see here, there are notes. For every video, you can create notes and you can timestamp the notes, right? Here is a timestamp, 20 minutes, 53, right? What I'm now, let me see where we are here. I don't know, well, I jump in the middle part here, 44 minutes, and I say here, yet another note, right? Adding a timestamp. And then you have a note, and later on when you rewatch a video, or you say, for example, oh, this is a topic that is important, but I didn't get it for the first time, I want to revisit it. You can make here notes, general notes or timestamp notes, so that you can jump to the notes later on again. So that's the video part. Of course, you can have open this. I'm working here, as many do these days, with 2 screens. Right on the left-hand side, you could run your video, on the right-hand side text, or the other way around, or you have even a Jupyter Lab, the text open plus the video open. So this should all be working. Multiple tabs, no big deal, as with any other platforms or applications that you use in the browser. Right. So that's the point here. Yeah, I think I've answered the question here. Can we make personal notes? And yes, these are all personal notes. So if you make a note, you don't see mine, and vice versa. If you make a personal note here up there in the upper left-hand corner, I won't see it, nor will anybody else see the note that you make there. Right? So that would be the video session 01, which has, as you see here, 2 Jupyter notebooks, and I've clicked on the first one. There's no double click required. A single click is enough. You see it takes a little bit, and we are in the game of executing the code for the first session of Finance with Python. You see, this first Jupyter notebook is a pretty short one. You can through it, you can execute it one by one, and you are done. Here, pretty fast manner, right? Later on, not that fast maybe, because the Jupyter notebooks will be growing and will be a little bit longer. This is, I would say, for sure one of the shortest ones that you will find in the class. You need to be careful with one important aspect, and I emphasize it, that's one important aspect. You will see throughout that whenever you open such a notebook here on the Quant platform, you cannot save it. Right? When I go here to File, Save Notebook, this is grayed out. Save All is grayed out. I can nevertheless save the notebook as, for example, locally or whatever. If I just execute the code, that's not a big deal, right? Because you will maintain the original version of the notebook there, right? But of course, it might be that you say, well, I wanna try something else here. For example, I wanna calculate here the, I don't know, the square of all the elements. Here I have changed the notebook, and now I cannot override it because this is read only, right? If you then want to nevertheless save it here, you can go save notebook as. Then you see here the path to the Jupyter notebook itself. So I'm now going and delete the first part here. Not even under trainings, I go even further back, right, and recall it. Rename it, not recall, I rename it my own copy. So when I now save it, this will work. You see now here the cross indicates that it has been saved, right? And I need now to go to the root level where you see the active notebook, my own copy. There are a few other ones here. One is called test. My own copy is now the current one that I have just saved. You see it also here with regard to the timestamp. You can also create your own folders, but be careful here when I navigate through the resources, and let's say I end up here certificate live sessions, your crypto basics, financial packages, let's say one of the most recent one. Here I cannot do anything. These folders, these notebooks, they are read only, right? So that's one of the major messages. If you want to save your changes, you need to change the name and the location, then you're good to go. Of course, I can close it, and later on, I didn't want to close that one. When I get back to my root level and I say, well, I don't need it, I can shut down the kernel And here I can afterwards also delete it if I don't want my own copy anymore. But I can't delete, let's say, the file, the original file, which is provided in your account from the Quant platform itself, right? So we have here in the overview the two modules, the reading assignments, and for every module you have the video plus the Jupyter Notebook, which you can execute on the Quant platform, or as I was saying before, if you're here on the portal and you say, well, I have done something, here is my own Jupyter Notebook or another Jupyter Notebook to this, and you can download the Jupyter Notebook here to your local machine and can execute it there or work with it there as well. Yeah, this is in principle how all the classes are structured. I said it before and I repeat it here. Not every class has a text, right? The major classes have text, but not every class. For example, just to mention, no, I was saying the major classes, Python for asset management, there is also no text available. I was thinking about writing a book for that one as well, but reinforcement learning for finance won out. Yeah, with regard to the options that I have defined for myself and discussed with the publisher. So the rest here should, after you have worked through one of these and you know how the Quant platform works, work similarly. There are certain classes where you find rather links to GIST than just Jupyter Notebooks, but this depends on the type of the class. So tools and skills is from the type of the exposition quite different, right? So there you find different resources, but the rest, for example, financial data science, AI and finance, and the optional classes throughout. Here's also one exception: the Python for Excel class is also slightly different because, yeah, you need different resources. You need Excel spreadsheets, which you can't execute on the Quant platform, which you need to download and work with on your local machine, for example. But I'm pretty confident that you find your way through. But there's, of course, the user forum where you can ask questions anytime. With regard to the content, how to do something, or where you run into trouble, let us know, let everybody know in the user forum. So for the time being, might be closing the Quant platform, and I want to continue our journey through the different classes. I was talking already about tools and skills. Here, indeed, we cover tools that are helpful with regard to software development, in part Python specific software development, in other parts general software development, right? When you edit code with Vim, you can edit other files as well. It's not constrained to just Python, right? Also here, Screen as a tool, as a very interesting, important tool on the Linux shell, or Q for logging. Q again is here a Python package in and of itself, a doc test, but Git version control is used basically for every programming language and other projects, right? Python packages, again, dedicated, documentation dedicated here, code hosting on GitHub. You all know there is much more on GitHub than just Python code, right? Of course, we are here in a Python for Finance program, therefore larger parts are for sure for Python only, but other parts, this is what I wanted to convey here, are also helping you out in different contexts. So you learn also general skills beyond just the Python specific ones. I think that's kind of a nice element here as well. Overall, with regard to setting up the infrastructure, Jupyter Notebooks are kind of the goal with setting up the infrastructure, because once we have reached a point where we run Jupyter Notebook or Jupyter Lab on a local machine in a Docker instance or on DigitalOcean in the cloud, then from there it's more or less just a matter of adding additional packages when we need them, right? That's the point here. To set this up, to make this as efficient as possible in the tools and skills class, you will also see scripts that more or less automate the whole procedure in different contexts. I think, and this is the feedback that I've received over the years from many of our delegates, I've never worked with cloud instances. Now, when I fire up a DigitalOcean, DigitalOcean Droplet and set up my Python infrastructure, it feels like second nature. And this is, of course, I would say one of the best feedbacks that we can get. From the structure, again, videos plus resources make up the class here. But if I was saying practical skills is the major goal here for tools and skills, that's the overarching goal. Right? I mean, it even has skills in the header. So just reading something on the web about it won't make it for you. You need to practice that stuff for yourself, and don't be shy. Just try it out, give it a try, play around with it, and see it as a learning journey indeed, where you might have with one or the other topic a few issues in the beginning, but later on it will get better and better, faster and faster, and more efficient with every step that you take on the journey. Python for financial data science, there's not that much to say. We cover here the most important packages, approaches that you need to efficiently process data. So the subtitle, which was changed for the second edition here, Mastering Data-Driven Finance, that's more or less the summary for that class, with topics such as financial time series data, stochastics, statistics, a bit of machine learning, mathematics, data analysis with pandas. And pandas, NumPy, for example, is something that we'll find in basically every class, almost in every session that we do. Again, you have the text, you have the videos, you have the resources, Jupyter notebooks, and quite a bit more. So the full-fledged package is available and ready for you on the Quant platform. That's now something brand new, which we have added in the previous cohort. So just a short while ago, financial packages. This covers such interesting packages which are small and pretty efficient for a specific purpose, like quant stats, and also, let's say, powerful packages for vectorized backtesting on a large scale, like vector BT. So as it stands now, this has 6 sessions, and there will be additional sessions and packages that we cover come later on. But with the ones that we cover, and I try to come up with the combination of packages here where you have synergies between the packages, which I always find nice, that you not only work with one thing and then you turn your attention to a completely different thing, which has nothing to do with the first thing that you've covered. So here I tried indeed to have a set of initial packages which are pretty useful, and you will have what is shown also in the sessions themselves, quite a few synergies between the packages. Python for Excel. I know Excel still is one of the most important tools in the financial world. So here, everything about the integration of Python with Excel, the capabilities have become better and better, have grown over time. It's a wonderful thing, as I would like to say, because we cannot define away or wish away Excel. Many people even love it, right? But adding the power, the analytical power of Python to the easy to use, let's say, graphical user face here, the spreadsheet application that has grown into so many different areas, I think that's really a major benefit. So if you are struggling maybe with writing efficient VBA code, this, for example, just as one example, might be your way out. Use Python and replace maybe slow, maybe inefficient, maybe hard to maintain VBA code, for example, with the appropriate Python implementation, using pandas, using like all the powerful things that you learn about in the program. Data is what fires the Python for finance machinery. Data is the new oil, and people say, well, it's even more important than oil these days. I don't know. That's a debate for others. But one thing is for sure, we have multiple options out there to store data in an efficient way. So there are SQL and no SQL options with regard to database like MySQL, which is standard database, SQLite, which comes already with the Python interpreter, MongoDB as object-oriented storage database, right? PyTables for efficient binary storage, SQL Alchemy as an abstraction layer, which is Python specific, or bcalls is a little bit of an exotic package, but nevertheless for financial applications and large financial data sets that come in tabular and columnar format, pretty efficient. And when I talk about efficient, I usually have two things in mind. The one is how difficult it is to write code in order to use the different technologies, and how fast the technologies are with regard to managing the data here. And there are quite a few, and not only with the overall comparison, but in between, you see here many speed measurements, comparisons, etc. And you might then learn about the advantages, disadvantages, or specific strengths, we can say, of the different technologies, right? Structure here again slightly different to the benchmark case, because here you're supposed, and that's the reason why you should study this a little bit later, you're supposed to execute it all on a droplet remotely, because, for example, the setup of MySQL database is a bit more involved, but you find all the scripts here in the class, and the for example, data sets that I use that are written to disk, etc., are quite a bit larger. So we simply want to prevent you from killing your own machine and messing up with your local machine. Therefore, do it a bit later, fire up cloud instance, and do it safely, well beyond your own local infrastructure. That's, I guess, here the specific approach for that particular class. NLP, as I said, it's a pretty short class. But nevertheless, you will see here how to process data efficiently. And data here means unstructured data, not like the numbers that we're so often dealing with in finance, but really text like HTML pages and other text-based resources. AI and finance, everybody's talking about it thanks to ChatGPT. Feels like the first real summer here heating up around that field, even like CEOs and CIOs calling for a stop of the training of the large language models, right? Seeing dangers and risks on the horizon through building ever more capable technologies. For me, I must say, when I first read the book Superintelligence by Nick Bostrom quite a few years back, not when it came out in 2014, but this is all about AGI, artificial general intelligence, or even the superintelligence, which might come up one day. It all read like a science fiction novel, but now with a tremendous progress that we have seen over a very short period of time, I think what he was writing about and published in 2014 has become ever closer. And back these couple of almost 10 years back, and maybe even 5 years back, many people said AGI might be even 50 years away. Now people say, well, who knows? Maybe it's just like 5 months and AGI comes around the corner. I don't have a strong opinion on that. The only thing that I observe is whatever I've read in the past with regard to forecasts of periods of time, how long it takes to accomplish the next milestone, practice and the genius people out there have proven the forecasters wrong, right? Even large group of experts in the field. So it is important, it is there to stay. We'll see, I guess, quite a few interesting things even for the remainder of this year. At least you have access to the text here, AI and finance, as before, right? With the PDF version, as well as also still quite a bit older HTML version. And even here in the beginning, superintelligence, you read here the traditional text by Kurzweil or some others who were writing like quite a while back about superintelligence. And I said it now, many people now, people such as Elon Musk are now afraid of that superintelligence might be around the corner, and are worrying about the risks and dangers that might arise from that. So here you need to be careful with regard to what you find on the Quant platform. There are 2 classes with 24 module sessions each. So the one is the class which goes along the lines of the book AI in Finance, and the other one is the class which is more focused on building neural networks, for example, from scratch, and illustrating how this all works with pure plain vanilla Python code, not necessarily using any package that is already out there and doing the trick. So if you like, the one is more about the application and the other one is more about understanding what is going on behind the scenes. So therefore here you have quite a bit of input, 2 classes with 12 modules and a lot of code each. Reinforcement learning is yet another class. It's not part of the AI in Finance. It's, if you like, the 3rd class dedicated to AI in Finance. And this has the background here. You might be fully aware of what I'm showing here, like how it all started to become much more popular, like by playing Atari games on superhuman level, based on the breakthroughs of DeepMind, right? Then AlphaGo, which even brought it to mainstream media. There's a documentation which you can watch for free on Netflix, 1.5 hours, how this all turned out, how they got there, and when finally in 2016, beginning of 2016, AlphaGo was able to beat the back then world champion. And speaking of the forecasts, for example, in the book, again, Superintelligence by Nick Bostrom, you find the prediction that it might take another 10 years, right, until AI-based computer programs, generally speaking, agents, they are often called as well, will be able to beat the world champion in Go. Yeah, the forecast 10 years was in 2014, but it happened already in January 2016. So this is what I meant, right? Basically, all the forecasts that I read about in the past, they were proven wrong by a large margin. So 2 years instead of 10 years, and with the large language models, where now these models are able to pass tests, on average on almost superhuman level, or at least human level, let's say admission tests for universities, etc. And that's really impressive, I would say, right? Here you learn the basics from the background of playing games. This is where, for the first time, this was applied on superhuman level. But of course, there are so many other applications. But I thought it is fun to get into that field based on playing games. I hope you find it fun as well. But of course, we then enter the world. Here are 2 examples when I click on them. Where you can watch a video, what you will learn in that class, right? But of course, then the applications will be here on the financial side of things. So from playing games to trading in the financial markets, that's here the subtitle, and this, I hope, is what the class delivers. You learn the basics, you learn them in a playful context, and then you apply the learned approaches to financial problems, like building a trading bot, for example. Python for algorithmic trading, one of the core topics in which you, for example, could prepare a final project. Book is there, text, all the resources, and without going here into the details, we have basics that are covered there, like vectorized backtesting, prediction-based trading, event-based backtesting. Then the platforms are covered. So here probably there will be a few changes, given changes that we have seen in the past. So this might be updated because I'm planning to do a live session, so a new run, if you like, an update of the existing class that we have. So this is not yet completely decided what we will be focusing on, but with a higher probability, I would say there will be certain changes, at least to what we cover there. On top of that, you will have practice modules towards the end. And as I said before, you can decide, for example, to do your final project in algo trading, but this doesn't have to be. You can also choose other topics. Here you see the overview, 7 layers. This is what we cover. Many layers are covered repeatedly: infrastructure, data, strategy code, backtesting, connecting code, trading code, automation. And then we have here the master class. ONA is what we focus on primarily because it simply has the best technological integration, best API that you can get here, with a ton of data, with ease of use, efficiency in terms of usage, speed as well. So ONA, I think, and this is from more than 10 years of doing that topic with Python, is the best environment for me, at least with all the hundreds of hours and hours of teaching and writing of experience that you can get to get started. Later on, when you say, well, but I want to change to another platform, that's perfectly fine. but you might notice maybe later on then as well that not every other platform is as technologically advanced as what we see here with regards to O&A. Python for computational finance, the traditional quant finance arena, right? About derivatives analytics primarily with Python. Here you also see a translation of that book. And the topics here are market-based valuation, which is the overarching topic, if you like. We cover complete market models such as binomial option pricing, such as the Black-Scholes model in detail, risk neutral valuation as a general approach, Fourier pricing theory and applications as a numerically efficient approach. For calibration of models, we cover American option pricing in detail, which is a bit more involved than pricing of European options. General market models, including stochastic volatility, jump diffusion, stochastic short rate. So it's not the most general market model, but when we think in terms of single asset models, meaning we are not dealing, let's say, with basket options or whatever, then this is indeed a pretty general model. Monte Carlo simulation as the numerical method that is required to implement these more advanced models in numerical applications, plus then building on top calibration, hedging, plus a review of the topics, and also practice, right? Practice here and there on the charts you find it, but even if you don't find the word practice or practice modules or project, right? It's all about doing it on yourself and acquiring the skill, and not just like going to the movies, having a good time for 2 hours, eating a bit of popcorn, and then with a smile on your face, driving back home. It's about doing the stuff. It's about learning to play the piano. It's about learning to swim. It's about learning to drive the car. There comes the point where you need to play, where you need to jump in the pool, where you need to jump on board of a car and go into traffic, right? And this is here with programming as well. There is, I should say, like a parallel class about listed volatility and variance. Derivatives might be a bit specific. I'm not going here and do the details. For those of you who are dealing with this so important and also interesting, exciting asset class, you find here quite a bit of background implemented as usual, of course, based on self-contained comprehensive Python code examples. We also have, again, if you like it, as a parallel class, as an add-on to the core classes, here DX Analytics, our open source package with which you can implement most of the methods that are shown in the core class, but even also quite a bit more, right? So this is what you find there as well. I would say it's not really required if you say, well, I'm not like here interested in this package primarily, but you might see quite a few benefits in using the package to implement the numerical methods that we cover in the core class, because it gives you a standardized framework, also efficient way of modeling your derivatives and of pricing even, let's say, pretty exotic derivatives. Here, a schematic overview of how DX Analytics works, maybe for our intro and overview here, a little bit more detail, but maybe also for those who are interested to whet your appetite, we will cover here the details of the DX Analytics modeling approach, which goes beyond the limitation that I mentioned before, like single assets. So here with DX Analytics, you also cover basket options, so multi-risk derivatives, etc., and portfolios of derivatives, and quite a bit more. So the package gives you the flexibility and also efficiency that you need in order to get on to that level in option pricing and hedging. Here we have the 8 layers that we cover. Infrastructure always is required, data, the model, simulation, Fourier pricing, calibration, which is made possible in an efficient manner by the use of Fourier pricing, then the market-based valuation plus hedging, which might be one of the goals that you have when you calibrate the models and implement the market-based valuation. Last but not least, with regard to the core classes, Python for asset management. Sometimes I like to say algorithmic trading is a multi-billion-dollar industry, but asset management, investment management is a multi-trillion industry. So you could find arguments, this is what I want to say, that asset management from an overall perspective is more important than algo trading. From an industry point of view, this might be true, but from a personal preference point of view, you might say, well, algorithmic trading is what I'm most interested in. Anyways, no matter what your own motivation is, here you find everything about the basics of risk and return in finance. Mean variance portfolio theory obviously is at the core. Capital market theory such as the capital asset pricing model, arbitrage pricing theory, and alternatives to the standard theories are presented there. So it's all practical, right? Necessary financial background information is provided, but as usual, it's all practical. And we add, as with so many other classes, AI and machine learning to the mix here. When we cover, for example, Black-Litterman, the Black-Litterman model, we use deep learning models to predict returns and use the return predictions as they are called views, investors' views in the Black-Litterman model. And for those of you who don't know about these approaches and methods, go through the class and learn these very interesting models and techniques. They also help you in other contexts, I would say. If you know what I'm talking about, you might find here a few more examples with regard to Python code implementations, backtesting, like rolling backtesting approaches, which are not presented in the other classes in that level of detail there, right? There you see here the bullet, the famous bullet for the Python for asset management class, from traditional mean variance portfolio theory to AI for asset management. That's the subtitle, the slogan here for that class. Portfolio theory, a la Markowitz, is the starting point. The 3 asset case that you see defined here in mathematical terms is implemented. And I'm still amazed by this breakthrough, which dates back 70 years, 1952 it was published. So last year there was the 70th anniversary of the method, and we today with a few lines of Python code can implement it and visualize the results of it. I'm still intrigued, and many say, and I feel the same way, that this was really the breakthrough or the starting point of quantitative finance as we know it today. For the first time, a quantitative model was used and just relied on statistics, mathematics in order to form portfolios, and not that much about what is kind of like the future of the company and do I like the CEO or whatnot, right? Here it's a purely quantified approach of composing portfolios. With regard to the background literature, I recommend here, beyond what we provide, the book Introduction to Risk Parity and Budgeting. This is a pretty comprehensive and I think very well, nicely written book. It is quite advanced in mathematical terms, but the basic concepts are presented pretty well, and also risk parity, etc. And then the rest can be found in the other books that you have access to via our program already, Python for Finance and AI in Finance. Now the time has come for a brief demo. I said it during the introduction. I have shortened the list of demo Jupyter notebooks to make today's session a bit more efficient. I want to show you from the most recent class financial packages, the Quant Stats package, which is so useful in different contexts to analyze financial time series in general, to, for example, get in a very efficient way statistics for your algorithmic trading strategy returns, etc. Then model calibration and market prediction. I used to have an example with regard to efficient markets, but I want to, even if I don't show the example anymore, I want to emphasize the importance of the efficient market idea, which says basically that current financial prices in general reflect all the available news, all the available data with regard to a stock or to any other financial instrument, right? And in the model calibration context, we leverage the power of efficient markets by saying the market is always right, and we want to find parameters for a model that are in line with the market realities, right? Model calibration. Market prediction takes the opposite stands and says, yeah, markets show me certain prices, but I want to now outsmart the markets by saying, or by trying to predict, for example, that the market goes up tomorrow with a higher probability than it will go down. Therefore, I bet, let's say in this example, on an upwards movement in the market, right? But this, if you like, is yeah, an attempt again to beat efficient markets. Why so? Yeah, because if there is some information that leads me to conclude that an upwards movement is more likely tomorrow than a downwards movement, then this should be priced into the current price, right? But I simply say, oh, no, I have here some insight, wherever this insight might be coming from, that leads me to that prediction, and I trade on the prediction. If I want to trade or want to invest, I need to have a venue. I need to have means, which means instruments based on which I can implement my strategy, right? And therefore, I want to show here one platform which I've emphasized before. It's the O&A, is the Wanda trading platform, right? So let me open it. I have them all open already, my Jupyter notebooks. And when I get to the start here, you see that's a short Jupyter notebook. I've shortened this from the class. It's about the Quant Stats package. I do, as you will see, which is pretty usual for me, all the imports and configurations in the beginning. And there is the install procedure, which is a simple pip install Quant Stats, and I import Quant Stats. So I mentioned before that you can use it, for example, for generating statistics and also visualizations, plots for, let's say, the returns, the P&L of your trading strategy. This is what you can do. But here I keep it pretty simple. I generate metrics as well as plots for a plain vanilla instrument, and this is here the S&P 500. So I choose here just the S&P 500 from the list of available instruments. This is 10 years worth of data starting at the beginning of 2013. Right? It's end of day data, and I just pick the one ticker symbol and here pick out, for brevity here, the returns, the simple returns. And the basics here you see with that package, you can calculate, for example, Sharpe ratio, if you like, although often we do this for completely different things than just the index here, but of course with the return series I can do that. You see the approach here is QS stats, and then I call Sharpe, or I have the extend pandas option here, which gives me a Sharpe method attached to my data frame. Here it is a series object, right? So I don't want to teach you, I just want to whet your appetite, but I want to emphasize the approach here. So R Sharpe works as well. Or I can calculate the compound annual growth rate, 10.1%, the average winner, 0.007, the average loss, the volatility of the return series, here obviously annualized, and the value at risk in percentage terms. Value at risk of data ticker is the same. And what is shown here is that no matter whether I pass the returns or I pass the price series, it recognizes that this is the price series, calculates the returns, and then gives us the values, or consecutive wins, consecutive losses, 8 and 9. So that's the largest number of consecutive wins, a win streak, and this is a losing streak. So plotting here, snapshot, and just by calling this method, we get the performance. We get here, as you can see on the left-hand side, a drawdown, and also the daily return. This is what they call a snapshot. Overall summary, drawdown, pretty important. Here you see, for example, volatility clustering around downturns. You have higher positive as well as negative returns. So volatility typically increases, often dramatically during crashes. So the drawdown exclusively, here the average drawdown that we have, plus the drawdown over time. See, I need to scroll here, given that I have zoomed in a bit. When I zoom out, we see the complete plot here. Drawdown periods can be also visualized here with the background, what is this, light red background boxes, which illustrate the drawdown period. So monthly heat map with regard to the returns. You see here the worst month easily spotted, right? This was in 2020 March. That's the COVID crash that we see here. Or the yearly returns. If this is of particular interest, we can debate. For example, from an asset management point of view, this might be something of interest. Or the metrics in basic fashion, which means it's not exhaustive. You see here quite a few cumulative return Sharpe ratio, but also more exotic ones here. Where do we have them? Sortino, Omega, maximum drawdown we have seen before already, gain pain ratio, month to date. And you see the message here, that's a package dedicated to quantitative statistics, and it's pretty efficient to do it, right? I import my time series, and with a few keystrokes, a few characters typed out, meaning here a method calls, I have my basic statistics delivered here, right? And I get also here something against the benchmark. Here, I just wanted to show here that you can put a benchmark. I only have like one time series that I've picked out here. I could also use another one. Let me maybe do here data, for example, Apple. Let's see if this mix works. There's some, oh, it's not in data, of course, it is in raw, maybe, if this works. Yeah, here we go. And it calls it strategy, although this is now just a plain vanilla instrument, right? But you see here the language is strategy. So then you can compare here your Apple stock price against the S&P 500, or a few more plots simply here with a single method call, or basically the matrices as well as the plots with a single call. You see here, this is just typing out reports and basic, and you get the statistics, plus you get the plots there. So it might not be the best thing since slice spread, but to generate important financial statistics for any type of time series, and I see, for example, in the backtesting arena, like, or also in asset management, very good use cases to use this efficiently to generate nice plots without re-implementing and reinventing the wheel over and over again. So that was just about statistics and the newest class that we have, financial package. So option pricing based on a market calibrated model. Here's a bit of background for the jump diffusion model, which is implemented here in Python code. More details are provided and discussed in the computational finance class. Right now, a numerical example, and with all the implementation up there, we can value a call option here based on that model, which has a jump diffusion element. You see here beyond the Black-Scholes Merton parameters, we have a lambda, mu, and delta. So 3 more degrees of freedom, 3 more parameters that we can use. This allows us to calibrate the model according here to a error measure. This is the root mean squared error that we use in order to minimize the error between market observed prices and model prices. That's one of the standard approaches in quant finance to implement market-based valuation. So here I retrieve options data. You see there are prices for call and put options. In what follows, the call options are used. The call prices over a certain range of the strikes are used here. And the error function is implemented. So this, you see here, requires a few lines of code because it's not the error function only, which is here in that part, right? It It also checks for parameter values, etc., and returns penalties in certain cases. So it's a little bit more involved. Right? The calibration now is done in 2 steps. The first is a brute force one, and this is discussed again extensively in the computational finance class. So we first scan the sensible surface of parameters. So here it's multi-dimensional. It's difficult to speak of a, or to think of a surface. We can easily speak of a surface, but beyond 3 dimensions, we might have a little bit of a harder time. And after this brute force scanning approach, a local optimization starting at the previously found best place, if you like, on the surface is implemented. So that here, global optimization in combination with local optimization gives us first a error which is here slightly below 1, and then after the local optimization, we see a further improvement of 0.2. So when we now compare the market prices with the model prices, in an ideal world, they should be exactly the same. But this is in an ideal world. In the real world, they are, in a good case, almost the same. And this is what you see here, right? On the first chart, when I just show you that one, it almost looks as if the model values, the red dots here, lie on top of the blue line. And they are almost on top of the blue line, but here you see the difference is visualized. So we have price discrepancies between the model and the real world prices, right? And this is what is to be expected. We can have a good fit, but in general, the fit of the model will not be perfect. Given certain market conditions, this can be better or worse. We also could change the model to have more degrees of freedom. But here overall, I would say this is not too bad. And it's much better, much better than what a simple Black-Scholes model could provide us with, because we see here the effects of implied volatility reflected. And this is something that we cannot take into account when we just work with a Black-Scholes model. But more on that, again, here just to whet the appetite, more on that in the computational finance class. So now market prediction. Again, a quick run through, if you like, a few imports, and then working here with data from O&A. The data here that is retrieved is a fixed data set that we use here and there in the program, and we generate a couple of features, right? A couple of features. Also, I should mention this is intraday data, right? We use here a couple of features such as the difference between high and low, or simple moving averages, momentum, volatility, and a few more financial features which are one after the other defined here. Right? We have a total of 21 features that we use, right? Then do a train, validation, and test split here using 10 lags, normalization. You see, I run through it. It's not a teaching session again. And then we use a neural network based on the historical lagged features. 21 times 10 lags is 210 features that we use here. The model fitting takes a little bit. It's a deep neural network. If you have worked with them, you know so well that this might take pretty long, depending on the size of the neural network and the data set, right? And then we do a back testing here. So back testing, we have plus 4%, minus 4% for the passive benchmark investment. And there we go. And for example, now the third time that I repeat it, you could use quant stats, for example, to analyze here the data one against the other, right? One against the other, I mean the strategy itself against the passive benchmark investment. So that's AI in a relative simple context here, based on lagged historical financial features, applied to the prediction problem, right? Here, market prediction. Model calibration leverages efficient markets, saying market is always right. market prediction says I'm smarter than the market, or my model is smarter than the market, and I try to come up with predictions that lead me to investments or trading decisions beyond just a passive buy and hold strategy. Right? So these are the two basic approaches how to deal with market efficiency. Either you declare it your friend or you declare it your enemy. A ton of effort is in the financial industry put into two basic approaches, in outsmarting the markets as well as living as good as possible with what the market do on a daily basis. So the Wanda trading platform, let me maybe open my trade app here. This is not correct starting point. Trade Wanda. This is one of my demo accounts. I should be logged in because I was logged in today already. So this is the typical, let's say, day trading like application where you see if you like real-time information. This is now on a one daily basis. I can change this to 5 seconds, for example, and zoom in quite a bit in the US SPX. This might not be the best one here. Where do we have the euro US dollar? This is basically active 24/7, right? So we now see here the real-time action, at least real-time at the end here, 5 second bars, how the currently is pretty quiet, as you can see here. So there are many tight intervals here, so not that much happening. But that's not a major point. Of course, you have that with basically every trading platform out there that you have your interface, your graphical user interface, right? And I want to rather show you now that we can do algorithmic trading here from the Python side, from the Jupyter Lab. I have installed TPQA, a wrapper package around the API usage. I have stored my credentials here in a file so that I can access now just to check. Yeah, I can access instruments. Going now with BTC US dollar. Here I can retrieve historical data. So I'm retrieving here 2,878 data points. When I plot this, I'm here in the game. I can change that as well here to, let's say, the 2nd of May to the 4th, that we get data a little bit later here in the last week. So pretty current, but still historical data. Static data, there is no change anymore to be expected here. Now, when we want to backtest a strategy, let's say a momentum strategy with 60-minute bars as the momentum, see here the hit ratio is calculated. So the trues and falses with regard to my next minute prediction. You see we go 1 minute by 1 minute. And we have here a pretty bad hit ratio, I would say. When I do the vectorized backtesting, oh yeah, that one doesn't look that good. It's roughly ending up where the passive benchmark investment is going on. So I didn't do any data snooping here to present a nice case, but maybe the original parameterization gives us a little bit of a better result, so that we see at least a difference towards the end and not something which is more or less the same. The numbers here didn't change that much, but this doesn't. Here we now see already from the numbers a difference, and indeed it looks completely different. That slide here, I'm not in the business of selling you anything. We never do, never ever, right? Do we say this is a strategy, this is the approach that you should do? We are in the business of showing Python approaches and teaching Python skills that empower you to do your research and to implement your strategies. At least we see here a good result, but more or less by chance. Before you saw the result was completely mixed and more or less on the same level toward the end as the benchmark investment. But let's assume, right, you have done your research, weeks and weeks of research, detailed analysis, you have analyzed it from every angle, you fully know all the statistics. Maybe you have used quant stats to enrich your statistics beyond just a simple returns measure, etc. Right? And then you can say, okay, let's have a look at how many trades we do here. This is now the visualization of the trades. Here we are long, here we are short. And then the next step might be that you say, well, I have reached a point. And again, we teach you all the skills that are required to deploy your strategies in an automated fashion in the cloud, interacting via APIs with the trading platform, in particular with O&A. And therefore, if you want to implement the strategy, you need to be able to execute trades. And here you see now the execution of the trade. So I create an order here, PCO USD units 100, right? And let me check whether we see it. I'm in the right account. It took a little bit, but you see here now BCO, Brent crude oil, 100 units, a long position. That's the margin that is required. That's the current price. Yeah, you see it more or less in real time. So the order is placed faster than what the graphical user interface, the web interface, shows you here, right? And then I can say, oh, well, I want to reduce my exposure by 50%. You see here units minus 50, and let's check. Yeah, 50 are left. My long position has been reduced from 100 to 50. The margin requirement has been reduced from 700 to 350 roughly. I have made a tiny little profit. Maybe we should try to secure that profit by closing out the position, and the position has gone. When I now have a look at the activity, we see the, oh, indeed, my uninformed, randomized trading here has shown two profits. With the first closure here, by reducing by 50%, I've made a profit of 1.13, 1.58. Here, even my overall balance here has increased from 100,000 to 101,300. This here for me, it's just to have a visual check of whether the trades have been placed, etc. So I don't basically need to have this open. The API works without the graphical user interface. That's the very idea of an API, although I must say, and this is indeed kind of a critique, that when you deal with interactive brokers, they expect you to have your TWS, your trader workstation, open, up and running in order for you to be able to use their API. I think it doesn't make sense because it basically prevents you, for example, among others, to run your code efficiently in the cloud because TWS is only with a ton of effort executable on a cloud instance, so headless, right? But that's a different story. This is just additional emphasis that it should be the standard case to use an API without any type of application or graphical user face up and running. Here I pick out the order ID and get, for example, the most recent information. You see the absolute detailed information here with regard to the previous trades. For algorithmic trading, what we also need, and that's the final illustration here, in this Jupyter notebook, we need streaming data, real-time data, and here you see I'm streaming BTC USD data, which can trade. So it only prints out here. It prints the data. Of course, when you would do algorithmic trading, you would need to collect the data, you would need to process the data, you would need to generate signals, you would need to automatically create orders and whatnot, right? There is a ton more to do, but I want to here show you the prerequisite, the capability to place orders via an API and the capability to retrieve real-time data via the API. This is what you need on a very basic level to do algorithmic trading. Yeah, that's the demo and the cases part, just to whet your appetite, just to give you a bit of a flavor of what to expect. There's of course much more When I say 250 plus hours of instruction, you can imagine it's difficult to show you in 20-25 minutes basically a bit of everything. That's indeed quite impossible. So let me clear this up, and getting back to the overview here. Case studies and demos. This is what we have finished by now. And I want to have yet another look, now that you have seen what to expect in the program, what the resources are, the study plans. There are two types of study plans. The one is the one that I have shown you already before, where you start in week number 1, where you also see in the overview the live sessions there, right? And then we go week by week. Only from week 4, we specialize with regard to the core topics: asset management, algo trading, computational finance. In the beginning, the first 3 weeks are about laying the foundations, getting started with the basics, so that everybody should be on the same level that we then can leverage in the other classes, sessions that follow afterwards. So overall, you can also say that every 3 weeks you will reach a milestone. The review questions that we provide you with, they are also for every 3-week part here, right? Here, 3, 3, 3, and the final 3 here, right? So that's the idea. This is your guidance. If you say, for example, time is a scarce resource for me, you can, for example, safely skip in the beginning the optional resources. Some even say, well, Excel now is not a topic for me and probably won't be any, so simply leave that out. So even if you leave it out now, it will be available for you for later review. And that's about the option. You even could in the beginning say, well, AI and finance, brand new for me, maybe I do this also a little bit later. It won't hurt you with regards to the other classes there. But from a certain point on, like an algo trading, etc., there is then the time and the parts that are covered are about applying the techniques that are introduced here in that part, right? If you have questions in this regard, feel free to go to the Discord server or the user forum, and we can discuss what makes sense, where you should focus on, and how to prioritize. Many of you also do it in a fully self-paced fashion, and there you also find a sample study plan, which is built in a way that the core classes are taught one after the other. So here I would recommend starting to start with the asset management part, then move on towards the later parts. But again, it's difficult with so many people studying and having their own special backgrounds, having their own ideas and goals that they follow to come up with a study plan that fits everybody. Therefore, these are suggestions, and if you have questions what to do and maybe how to prioritize it differently, how to change the sequence, feel free to go to the user forum or the Discord server, and we can discuss such questions there, also to the benefit of others. So sometimes you say, I don't want to, I don't know, spam the user forum with such questions, but I'm pretty sure that others out there as well, if you have the question and others might think the same way, then nobody's asking and nobody is benefiting. So put the questions there, make them as specific as possible, and you will find more friends than not, right? Because everybody benefits from you asking the questions and the discussion that you initiate based on that. So a few words on the guiding principles. Python first is indeed the guiding principle. So sometimes people write and ask us, how many strategies do you cover in the program with regard to algorithmic trading? Then I said, well, it's not that we are algorithmic trading first and we use a little bit of Python. We cover a ton of details that are required to come up with your own strategies, to backtest them, to implement them. So this is our focus. Therefore, Python first, and then we have examples. But it's not like in a, let's say, finance class, which uses C++ to implement something. It is indeed Python first. This is what we should always keep in the back of our head. It's also about specific implementations and examples, right? It's when you try to learn the piano, you can start with music theory, right? Harmonies, etc. Or you start by mastering a relatively easy piece on the piano first, and then you play it and you enjoy it. We are more on that side of learning piece by piece to use Python, and here and there we also provide more general, broader overviews, but the specific approach is what is first. So in other words, it's not a research theoretical exercise, it's again a practical one. Reproducibility throughout, so we here and there use APIs, but this is an absolute minority in terms of the number of classes. I have tried since years now to put it on a fully reproducible basis, that we work with fixed data sets that everybody can access anytime, and where the examples are reproducible without being dependent on your own credentials, on API availability, etc. pp. So that's indeed the approach here. And of course, it should be practical. I have invented the word. I've argued about the practical nature here. It's about acquiring skills, and not only about reading, listening, watching, doing it, playing the piece on the piano, jumping in the pool, driving the car on your own. And this might also be noteworthy here. I'm pretty sure that some people, and I've used this slide for the first time in the bootcamp last week, but it applies to a large extent to the program as well. So some classes might be simple for some delegates, but they find others more difficult, and vice versa, right? I know we have people that have a solid software engineering background, but little finance experience. We have finance experts that have little programming experience, and we have basically everything in between. We have also people starting from scratch, more or less in both fields. We have tried to come up with a composition of the classes and different approaches in different classes that cater to different people. Therefore, I would say be happy if you find stuff easy, and don't despair if you find stuff difficult. The more experience you gain with different topics, the easier it will become for you to master new skills and tools, for example. Basically, all the classes, apart obviously from the few Windows classes that we have, are based on Mac OS. So sometimes people say, oh, well, I was thinking of getting a new machine anyways. What would you recommend? And if you go through earlier classes like mentoring sessions that I did, I'm a big fan of Apple, not only because they look nice, I know it's because the overall infrastructure that you get there in terms of software engineering and everything else, I think is pretty simply the best that you can get today. I'm not arguing against Windows. I've used Windows many years of my life. I've worked with, even on a local basis, so on my notebook back in the days with Linux, ton of time. But you, again, I want to emphasize, you don't need to change your hardware infrastructure to follow along the classes. I'm only saying that most of the classes, almost all of them, are done, implemented based on Mac OS. I'm using that, period. And they are also executable, implementable on other platforms. But if you, and I have had this a few times, many times I can say in the past, if you are thinking about changing your hardware or whatever, changing the operating system, then feel free. And I know many people need to use Windows at work. Well, there's not a big debate then about that one. But when you can decide for yourself and you're reconsidering your recent choices, then you should give it a try. You can also discuss this, for example, in the user forum, or this is a good topic for the Discord server. So sometimes our exposition is opportunistic in terms of like things are presented as I see fit, but this might not then give you a comprehensive systematic overview. For example, with the financial packages, I tried to come up with, as I was saying, with a sensible combination to get started with, but I'm not providing basically, because I didn't see any sense in that, an overview of potentially all the financial packages that are out there these days that we might consider at some point in time, right? So that's often what drives me where I see fit. I use chances and design things opportunistically. In other cases, it is much more, I would say, systematic and comprehensive. Delayed rewards, something that I also want to emphasize is that not everything that it will do will give you immediate rewards and gratification. Sometimes it takes a bit, and I hope that in the end you will say, oh well, after all, now looking back 16 weeks or looking back maybe a little bit longer, 6 months, 9 months, I now understand and see how I benefited from stuff that I did in the beginning, which I thought, oh well, do I really need to do that, right? So I hope you will have that experience quite often, that even if stuff sounds or feels tedious, and then you don't see an immediate benefit of doing A, B, or C, that in the end, when it all comes together, for example, when you prepare your final project, that you will have a ton of delayed rewards. Every week you have one tutorial, plus every 3 weeks you have review questions that you can go through in order to check whether you understand the most important elements. Again, the review question is about understanding, the exercises about doing it on your own, right? In particular, the test projects. They might be sometimes a little bit smaller and more fun. Sometimes they might be a little bit more involved, where if time allows, you might spend half your Saturday in trying to solve such a project. In any case, try to prioritize the doing part and the practical part over the theoretical and passive elements of the program. So the user forum, I've mentioned it so many times, I should need to count it, how often. Always open. Make sure that you follow the guidelines with regard to what you post, and not like, I have problems with the code in session 7 of class number 4. Make it as specific as possible so that we can help you with your specific problem, and not try to figure out 2 hours on end what you might have meant with regard to what you have posted. We just recently had another example where somebody has posted 3 traceback errors without the code itself. We simply cannot help. If you don't provide the full information, we cannot help. This is like saying solve math problem 7.1. Then you would say, yeah, which book, which whatnot, which context, right? Provide all the details that are required. That's the major message that you should take here. The Discord server, yeah, again, open. It's for organizational questions. We do every once in a while, we do live Q&A sessions there where we come together and you can ask questions in real time. You can also use it asynchronously, like the user forum, asking questions, I don't know, about hardware, about coding in general, about different approaches, maybe about events or some other stuff, right? This is beyond the technical part, but please do not post code here and ask content code related questions. This is for the user forum. Discord is nice, it can do quite a bit, but the user forum is for code, is for content related stuff, and you can also search the user forum. So maybe might be a good strategy if before you post something, there might have been a question that is tightly related to what you're asking. But in any case, we try our best to get back as fast as possible. Sometimes, I don't know, time differences might play a role with regard to the speed of our answers, but you have it available, and I'm also really happy when others help out. So other delegates of the programs or older users, by old I mean those who have participated years ago, sometimes are still active there. That's what I really appreciate. So expect us to follow up as fast as we can, and maybe some other helpful hands will also be there to help you out with your specific problem. Yeah, having said that, help learning, acquiring skills, and getting help from our side. I hope you now have a comprehensive overview of what the program, the certificate program in Python for Finance is all about, what to expect. You have seen there is quite a bit that we provide you with in terms of resources. Don't try to overdo it, in particular not in the beginning, to try to go through all the resources that you find. Try to stick to a study plan, try to stick to your own priorities and make the best out of it. I think I have provided you with a couple of guidelines with regard to prioritization, right? So that if there are questions open, this was the final part of today's presentation. You have the user forum, you have the Discord server, post your questions. In particular, in the beginning, don't be shy. We try our best to get back as fast as possible. But in the meantime, I wish you a pretty good, exciting start, and yeah, all the best, and in particular, happy Python for Finance coding and all the success that you wish for with participating in our program. See you in the next session. Take care. Bye-bye.